Good morning, everyone. I'm David Diaz, one of the tech leads for IPFS and libp2p. And this is an honor, a pleasure to be here with you all. We came a long way since the original creation of libp2p, and now we have a full community, multiple projects using it. I'm really happy about it. To give you an artifact of history, here is the original blueprint of libp2p. Like you can see, it's very self-explanatory. It has all the diagrams. Like people complain these days about lack of dogs. Come on, like, say it again. Yeah, exactly. That was saying. Yeah, it's using it. It's using it. Yeah. So as you can see, we had a lot of ideas, and they are way more clear now. So I thought it was the good time to do a libp2p overview talk, one that could introduce libp2p to a whole set of new developers. I have a simple agenda. I'll start with the motivation and why the heck do we still have to think about networking in 2018? Wasn't connecting the whole world like a goal of the last century? Like, why do we have to still think about this? And then with that motivation, I'll enter libp2p, explain what it is, what it can do, what it can solve today, then a progress report on the project, the community, the users, etc. And then just try to see what's out there, just put an idea of what we think will be the next things for libp2p. So if you have been following us for a while and been part of the IPFS community, you kind of have heard us say that we have this amazing platform, the web, that we love, that we learn to rely on, and that it is really fragile. A simple error in the backbone can completely kill all of the applications that you are using. And this problem really comes from this design decision that was made a long time ago that was really good at the time but kind of didn't scale, which is location addressing. And the proposal from IPFS is if we move to a content addressed model, we can solve pretty much all of these problems. The thing that doesn't get said often is that moving from a location addressed web to a content addressed web is not just hashing the content. You actually have to solve a lot of the problems in the networking stack. Reimagine how it was built to be able to get this connectivity to work very well. And so the networking stack and the internet in general has a lot of challenges. Things like firewalls and nets that blind users from seeing each other, makes it very hard for them to connect. High latency networks, networks that are really slow, it takes a very long time to get the response back. And reliability, right? There are so many places in the world where the internet is just not reliable. It keeps going down. The applications that are designed to work in this very robust networks that we are used to have access do not work there. And so we need to reimagine how to build applications that work without all the assumptions that we have from the more developed countries. Then there is also this problem mobile addressing, also known as roaming. How can we make sure that my processes, my machine, my identity can roam from device to device, and the other processes, the other machines can still find me independently of which machine I'm running. Today, that's done in a very centralized way. It requires always a point of coordination, but it would be great if we could just move from network to network and keep our identity with us. Then there's censorship, we have seen not that long ago, countries just collapsing the network for their users. There is runtimes with different properties. Today we talk about the IoT explosion, but the reality is that those devices, because they are more constrained in terms of resources, they have to use different transports, and those transports have completely different assumptions. And a lot of times, developers just don't go into that one. It's really hard to develop applications. And last but not the least is that innovation is incredibly slow in networks land. If you think that just distributed systems in general or the web, it takes some time to get some idea to be deployed into the network. If you think about transport protocols, even the companies with huge amounts of funding sometimes take a decade to be able to deploy a new transport to their infrastructure. And so these things and more were a lot of things that we had to solve in order to create IPFS. The thing is IPFS was not really the first peer-to-peer protocol. Peer-to-peer has been here for ages. And we kind of like, before even trying to solve all of these problems, we try to learn from other successful projects in the past. You might remember things like Skype. Like Skype, when it was originally launched, was a peer-to-peer voice application. It was not like a centralized one. Then you had like other things coming from file sharing, so Gnutella, Kazaa, Emul, BitTorrent, that also, in order to provide file sharing amongst their users, they had to solve a lot of these discoverability problems, connectivity, etc. And from the academia world, we got a lot of papers that, given that there is results for those papers, there had to be an implementation, but that implementation is really hard to be found. And so all of these challenges that were solved in the past had to be solved again and again and again, because there was no way to reuse those libraries, those software packages. And this is like a problem across the board in networks land. Like a lot of these projects don't have any documentation at all. They have like a weird licensing scheme, or like no license at all. That makes it even worse. Some of them are just super old. They don't run in like new generation OSs. Like they are not prepared. Typically, they don't have a governance model or even like one maintainer that you can like reach out to talk with. Most of them are like closed source, or like for the academia ones, a lot of the researchers just like write the code once, run their tests, publish their paper, delete everything because they don't care. And like no specification. Like the implementations typically don't expose like thought through APIs. They are like very tightly coupled with the use of the transport, the application itself. Like they didn't really care about others reusing those building blocks. And so this seems like a problem of the past, and like we love open source, and we are used to have these amazing readmes and like tests and like people testing things. But like actually no, it's still a problem today. One example is WebRTC. There is like more than 5 teams in the world, some open source hackers that are just using their free time, but actually other companies that keep trying to extract WebRTC from Chrome and repackage it in a way that can be used by others in the mobile platform or just like in the desktop. And yes, there is some good results, but they also keep failing. Like maintaining that transport, making sure it's bug-free is just super complicated. And so a lot of these previous projects made a lot of assumptions about the network stack at the time. Like they didn't have a way to really upgrade, or they didn't predict that the runtime could evolve, or that the project would live long enough that they would have to sustain through a change on the runtime. And so because they made all of these assumptions, today, like some of those old applications will never work in the networks today, because you just cannot, like it requires a complete refactor. So there had to be a better way, right? And probably, I know, like, what is the image that, like, you probably have in your mind is like, yes, like, there's always these solutions, right? So here comes the person in the white horse, like, propose a new solution that will conquer them all. Yes, like, this is a problem, but this is not what we are proposing. Like, what if instead of, like, creating a new solution that solves all the problems, we create a better way to integrate all of the previous solutions and open a platform that enables innovation, like that it enables other pieces to come in the future and add it to the stack. And that's where we enter in libp2p. libp2p, for those of you that are still new, it's kind of like the networking stack of IPFS, but extracted away, like made a first-class project, something that becomes a dependency of IPFS and not IPFS itself. So, excuse me. So right now, libp2p, it's like, again, a first-class project. It has its own community, its own ecosystem, its own set of users, its own priorities, and IPFS is really just like relying on it right now. Like it communicates its requirements to libp2p, and libp2p can evolve and get better. And so an intuitive way to think about libp2p is if you are very familiar with IPFS and the content addressing model, where you can like find, fetch, and authenticate any piece of data on the web, think about libp2p as process addressing, like a way to find and connect to any process on a network, independently of how many hoops you have to go over. And when you connect to that process, you can authenticate it. You are sure that you are talking with the right thing. And as I said, like it's something that's very modular. Like it's something that's very modular. It's composed from many, many, many pieces, and you can use one or more of these pieces and like just create your own puzzle, create your own recipe. All of these pieces expose very well-defined interfaces. We need these so that we can then have the swappability and the upgradability that we need in order to create a future-proof stack. And so there's interfaces for the top-level API, for the transport, for the peer discovery, for content routing, for peer routing, for record stores, for connection, and for stream muxers. It's a lot of interfaces, but this is like you can find these repos online. They're all open source, and they not only pack the specification that you need to follow, like the function signatures that you need to follow in order to create one more of those pieces, but they also bring a battery of tests that you can run against your own stream muxer implementation. And if the tests pass, then you are pretty much sure that you can just plug it into libp2p and it will just work. Another way to think about this is the OSI model. And I like to explain libp2p is we grab the OSI layering model, and instead of vertical, we made it horizontal. Just to make sure that everyone is on the same page, if you are not familiar with this model, the reality is this is a conceptual model. The internet as we have today is much more closer to the TCP/IP model, which was the one that got deployed, which removes some of the complexities from the OSI model. But even both of them are just conceptual models. What happens on the internet today is just a mix and shuffling of things. But these modules, conceptually or in practice, have some shortcomings. They repeat actions through multiple layers. You do stream multiplexing multiple times. You do authentication multiple times. You do discovery multiple times. You keep repeating this and this and this. And what it means is you have a lot of duplicated work, which consumes very precious resources. And not only that, it also disables you or makes you miss some really good opportunities for optimizations. And because other people already realized that a long time ago, what we see today is that we have transports, networking pieces that are not really in one layer of the stack anymore. They just try to grab a bunch of layers so that they can create these super optimizations. We have seen talks about Quick, and so for example, Quick is something that does the cryptography, there's the stream muxing, there's the hole punching, there's a bunch of things all together. And so this happens all over the place. What we did was, again, as I said, break this vertical system and just acknowledge that there are basic building blocks, things that we can define an interface for them, and let people use this frame, libp2p, to piece them together. And you might be thinking, oh, this sounds so complicated. How can we piece these things together? It's actually quite simple. Check it out. We have here two libp2p bundles, one to run in Node.js and one to run in the browser. And this is what JS IPFS uses. So when we switch from JS IPFS in Node to the browser, we only change one file. Everything else stays intact. Your application doesn't have to change one single line of code. And you can notice the differences here. The differences is that in Node we have access to TCP and WebSockets and other transports, but we by default use just these two, and multicast DNS, while in the browser we have WebSockets and WebRTC. And just by changing literally 3-4 lines, I can have an application running on the browser that is able to connect to Rust. This was not possible before. If you want to learn more about how these things work and how they piece together, we prepared some really awesome tutorials. They are pretty comprehensive. They will explain you what is a transport, how does it plug it in, what is protocol and stream multiplexing, encrypted communications, peer discovery, peer routing, content routing, all sorts of things. We'll go more in depth during the poster session for these as well. So yeah, this is exciting. Now we have a networking stack that not only works in many different runtimes, it also enables us to experiment and try new things. So what about progress? Today we have three main implementations, one in Go, one in Rust, and then one in JS. They all interop, they all can communicate with each other, they are all used for something today. Implementation in C# that is being built by a member in the community on his free time as he learns libp2p and explores more. So that's very exciting as well. And there's a bunch of pieces that are built in other languages because libp2p uses multi-formats very extensively. And so if you want to start something in another language, you already have a head start. The community is really large, and it benefits, of course, from the IPFS community that are very interested on networking as well. So we have 1,000 contributors throughout all of our repos, like commenting on issues, pull request reviews, doing the literature reading and review, and we have 70 people contributing with commits and pull requests. One of the tests of Fire for libp2p was really like this, like, can it run in the browser? Like, really planned, and it did. And we can run a node in Node.js and in the browser and connect both of them. Also, fortunately, it runs on mobile browsers too. So now you have a networking stack. You can like develop your app all in JS and run it in desktop browsers, mobile browsers, both iOS and Android. And it can use like all of the shiny features like WebRTC and whatnot. Yeah, cool. Yeah, I agree.
2 minutes if you want to split the time even.
Okay, thank you. I'll be quick. So yeah. Apps were built with it. We got a peer pad that uses libp2p PubSub to get that real-time feel when you are collaborating over the dock. We showcase how to move the Ethereum blocks from the Ethereum blockchain to the Ethereum VM running entirely on JavaScript on the browser through like multiple bridges. You can see there's like a Go node, a get node that brings the blocks in, moves the blocks to a libp2p node, and then those libp2p nodes can move into the browser, and like the browser can move to another browser without having to touch the network again. There's people building live streaming applications on top of libp2p. That's also very exciting. And our friends from MetaMask have been doing a lot of research on how to use libp2p to move the blocks from Ethereum chain in a way that's way more efficient for them. Like right now, they do a lot of calls and like they do a lot of fetches to like propagate the blocks into the to the MetaMask extension on the browser, and so they want to use libp2p so that browsers can help each other just load all of the information that they need. And of course, like everything that uses IPFS is using libp2p by design. Like we have all of these applications now relying on this networking stack. They just don't really know it yet. And anything that comes in the future on top of Filecoin will also use libp2p, inclusive Filecoin itself. Other very interesting projects, so Ethereum, as we saw here on one of the lightning talks, is exploring deeply the possibilities of using libp2p for the Ethereum network. And Polkadot also decided or is planning to adopt libp2p for their networking stack. An exciting development a couple of days ago, or maybe a week, was that there is now a demo of Polkadot.js syncing with the Polkadot network, which is in Rust over libp2p. So this was very exciting as well. And of course, last but not the least, we have a pretty sweet website. This is really important. Like for networking projects, like typically it's really hard to find documentation or even like a reference, like talks and so on. So this is kind of like unique in its own way. On timeline, and I just want to put a like caution here. Like this is like highly speculative. It's just like our best hopes and dreams, and maybe it's not even all of them here. And I think like Juan will speak more about this. But yeah, a short preview of the timeline. We want like JS, Rust, Go to achieve like complete feature parity, like to be able to do everything together. We want to help those language implementations by creating like very robust interoperability and integration tests. Just make sure that they are always running. And ideally, those tests should be projected out from a specification. So right now we have the spec v1 of libp2p, and it's more like an informative spec rather than actually a spec with requirements. And we want to publish the new one so that other language implementations can follow the spec, implement something that is interoperable from the start. And of course, we need some tools for network visualization. It's kind of cool to see all the nodes gathering with each other and like creating these like PubSub channels and minimum spanning trees and just like seeing them self-organize. 6 months, wild adoption. We want like way more people to use libp2p, try it out, check it out, build a lot of apps with it. We want to see more language implementations. Ideally, like the libp2p should get packaged in language runtimes. Like imagine like just getting your Python, your Go, your JS, and just like do require libp2p, and it's there without having to install anything. And of course, we want to start exploring packet switching. Right now, libp2p is very stream-based. That was the original design. But we want to enable libp2p to go even to more difficult networks through using packet switching at the application level. And we'll have a session on what exactly does this mean. In like 12 months time, like it would be ideal to have an OS level or like a OS level service or a kernel module, something that instead of requiring users to think about how to manage a peer-to-peer node in each of their apps, like you just have something that runs on the OS, and then each application can request an ID on the peer-to-peer network, and so you save a lot of resources through that. And like taught at university networking courses, and like go to all of the research labs and say, hey, like now you actually have this thing that is makes it so much easier for you to like do research and innovate, like experiment with, publish modules, be part of the ecosystem. Don't just like write some code and throw it away. There's like a lot of interesting things happening here. And like in the long term, yeah, like we want to be the default peer-to-peer networking stack, not necessarily by not letting other networking stacks exist, but really by being like this frame that all of these networking stacks can collaborate and cooperate. And this is like almost like perhaps like a personal objective. I want the world to stop saying client and server model, because that has so many problems and like makes so many assumptions about like how the network works. Like infrastructure works way better when we think about distributed systems, and like when every peer can like do everything that other peers do as well. And so yeah, this is again a projection just to give you an idea of the trajectory where we are going, and that is all. Thank you so much.